Welcome to the first video in Mathematics exam series for Victoria, Australia. In this series, we will solve questions in an exam 1 trial paper, which is a technology-free paper. We will work through questions cover the last 3 years, and we will use 2 to 3 videos to cover questions for each year. In this first video, we will solve the first 5 questions from a 2019 trial exam 1 paper. Hello Math Champions, I'm Dr. Chen. If you want to improve your math skills and understanding so that you gain confidence, enjoy math more, and get better results, click subscribe and hit the notification button so that you don't miss anything. Hello, this is the first paper of a 2019 trial exam paper for Mathematics in Victoria, Australia. Since this is an exam 1 paper, therefore it is a technology-free paper. This question shows us the diagram is a triangle with vertices of -4, 0, 0, 4, and a parabola with the vertex 0, 3. As shown in this diagram, this triangle actually is a right angle isosceles triangle inscribed by a semicircle. The dimensions here are given accordingly, and based on that information, 3 questions are asked. The first question is to express the parabola equation in its turning point form in terms of dilation factor k in the y direction. The question B is to determine the value of k in question A, given that the parabola is just fit inside the triangle. The question C is to determine the coordinates of the x-intercepts of the parabola. Now we try to solve these questions. Since the coordinate of the turning point of this parabola is given, therefore the parabola equation can be directly expressed according to the turning point form of a parabola equation, as we recall from what we have learned before. As for question B, the tangent line equation connecting the points of -4, 0 and 0, 4 is y equals x plus 4, while the tangent line equation connecting the points of 4, 0 and 0, 4 is expressed as y equals -x plus 4. This is quite easy to figure out, because the gradients of these 2 lines are 1 and -1. Both of their y-intercepts are 4. You may go back and see the diagram if you need. In order to now find the value of k, we need to solve these 2 simultaneous equations. And one of them is the line equation, the other is the parabola equation. After the replacement of y, it becomes a parabola or quadratic equation. Since the line is a tangent line, so the quadratic equation has only one root. Therefore, its discriminant should be 0. Thus we calculate the value of k, which is equal to -1 over 4. We back substitute the calculated value of k into the parabola equation and set y equal to 0. Then we can calculate the value of x, which is 2 square root 3 or -2 square root 3. They are the coordinates of the x-intercepts. Question 2 tells us the polynomial px can be factorized in the form of 6 vectors. Based on that, question A asks us to expand the given factorized form, while question B is asking to find the value of m if px can be factorized in the form of x squared minus 1 times bracket x to the power of 4 plus m times x squared plus 1. Question C is asking to factorize px in the form of 6 factors, And the last question is asking to sketch the graph of px. Now let's try to answer these questions. For question A, we first treat a plus 1 as a variable and square root a as another variable. We group them in such a way, then we can apply the formula of the difference of two squares to get the expanded result. For question B, there are two approaches for this question. The first one is to expand px containing m, then set both of the coefficients of x the power of 4 and the quadratic terms to 0. Then we can find m equals to 1. However, the alternative approach is to factorize x the power of 6 minus 1 directly. Here we express x to the power of 6 as the cubic of x squared. Then we factorize it in a way we can apply the formula of the difference of two cubes. The factorized px can be used to compare the px given in question B, and in this way we can calculate that m also equals to 1. For question C, the polynomial x to the power of 6 minus 1 can be factorized by using the formula of the difference of two cubes. The bracket containing the x power of 4th can be further factorized by adding and subtracting an x squared term. Then we factorize them again, as it can be seen in the display. In order to sketch the graph efficiently, we need to pay attention to the following list of things we need to do. First, observe the function carefully, since each function is unique. We also need to find out if it is an even or non-even non-odd function at all. Second, if there is any stationary points, inflation points, or even asymptotes. Number 3, work out the x and y intercepts if it has any. Number 4, build a table of x and y values containing a number of important data points that will show the feature of the function. Number 5, smoothly connect these points. Here we show the sketched graph of the polynomial px. Question 3 is an index equation. Since e to the power of negative x is greater than 0, therefore we need to be aware there is no negative answer for this question. To simplify the question, we are assuming y is equal to e to the power of negative x, and then solve y. And we can solve e to the power of negative x, which is equal to the square root 3 over 2. In this case, there's no negative square root 3 over 2, because e to the power of negative x is always greater than 0. Question 4 is a logarithmic function with a parameter a. Here a is defined as a real number except the -1 and 1, 2 points. The first question is to prove this function is an even function. The second question asks us to show that fxy is not equal to fx plus fy within the defined domain. The last question is to show the derivative of the function is an odd function. Based on the rule of fx, substitute negative x for x and proceed to simplify the expression. In this way, we have proved f negative x equals fx. For question B, again, we substitute xy for x and proceed to simplify the expression. In the meantime, we also simplify fx plus fy, and we find that they actually do not equal to each other. Question C. We do the derivative of fx first. Then we substitute negative x for x, and then simplify the expression. So in this way, we have proved the derivative of the function is an odd function. In question 5, we find the index of both function fx and gx are in fraction form. Particularly for gx, the denominator of the index is an even number 2, which means the domain of gx must be 0 or real positive number. As for fx, since the numerator of the index is a positive number 2, therefore the range of fx can't be a negative number in this case. Now, we express the function in composite form. We start looking the result of fgx minus gfx, and we simplify them. Finally, what we got is fgx minus gfx always 0, which means the solution set for this question, for this function, is all the positive real number plus 0. If you enjoyed this video, please give it a thumbs up and subscribe to help me make more math content like this. I will see you in the next video.